Let's talk about converting between radical form to exponential form. When looking at radical form, the number in this location we call the index. The symbol itself is called the radical symbol. The expression below the radical symbol we call the radicand. When no number is in the index position, the index is 2. Otherwise, the index will be the number that appears in this position of the radical symbol. To introduce how to convert between a radical expression to an exponential expression, let's consider this example here. This is the square root of y. Since no number is in the index position, we know that the index is 2. When inspecting the radicand here, everything under the radical symbol, we just see y. We look for the power that everything grouped together under the radical is raised to. When no power exists, like we see here, we can imagine everything raised to the first power. Now that we know our index and we know the power of our radicand, we can rewrite the radical expression as an exponential expression. First, we set the group term raised to a power within a radical symbol as the base of the exponential expression. In this case, it will just be y. Y will be raised to a fractional power. The numerator of this fractional power is the power that everything is raised to within our radicand. In this case, it will be 1. The denominator of this power will be the index of the radical, which is 2 here. So the square root of y can be rewritten as y to the 1 over 2 power. Let's move on to another problem. Consider the cubed root of z all raised to the second power. My index here is 3. In this problem, I have my radical all raised to a power. Does that change how I approach rewriting this expression? In this situation, as long as everything within our parentheses is under the radical, we can treat this outside power as if it was the power of everything inside the radicand. So this will give us the same result as if I had the cubed root of z squared. Converting this to an exponential expression, we can write this as z raised to the 2 over 3 power. The 2 being the power under or outside the radical, and 3 being the index. Consider the 32nd root of the quantity y plus 1 all raised to the 5th power. Here, our index is 32, the base of our radicand is y plus 1, and the power of our radicand is 5. Since y plus 1 is grouped together and raised to a power within our radical symbol, it will be the base of our exponential expression. Y plus 1 will all be raised to the 5 over 32 power. The 5 being the power under or outside our radical, the 32 being the index of our radical. Let's move on to the square root of z cubed plus 5. With no number in the index position, we know our index is 2. Now, you might be tempted to apply this rule to both terms added together under the radical symbol and get this, but that would be wrong. Before converting to an exponential expression, we need to find the power of what everything under the radical symbol grouped together is raised to. In this instance, when everything is not grouped together and raised to a power higher than 1, we can assume that the power under the radical is 1. So when I go to convert this radical expression, I can rewrite it as the quantity of z cubed plus 5, all raised to the 1 over 2 power. When everything under the radical is grouped together and raised to a power, it can be rewritten as the group term as the base, raised to the power inside or outside the radical, divided by the index of the radical. If everything under the radical is not grouped together and raised to a power, the numerator of the exponential expression will be 1. For more help dealing with exponents and radicals, check out this playlist here. If you found this video helpful, consider subscribing, liking, or commenting on the video. I'm Joe, and thanks for spending some time with me.